Good morning for all students of grade 10. Welcome back after interruption due to quarantine and health problems. In this video, we are going to study about organic chemistry, but before to start, make sure you have a pen and paper to take notes. At the end of this video, you should be able to distinguish between organic and inorganic compounds, explain the importance of carbon in organic compounds, list some families of organic compounds, represent an organic compound using 3 different formulas. What is organic chemistry and why is it so important? Organic chemistry is the study of the compounds of carbon. Think about how organic compounds affect our daily life, our clothes, our medicines, our food, oils, perfumes, paints. As we could observe here in this document. For example, we have clothes or textiles, we have cosmetic products, paints, food, medicines or drugs, and fertilizers. Introduction. What are organic compounds? These are compounds which contain carbon as an essential element such as gasoline, drugs. Other than carbon, they can contain hydrogen, oxygen, and other chemical elements such as chlorine, sulfur, and phosphorus. What are inorganic or mineral compounds? These are the compounds that do not contain carbon such as minerals called ionic compounds, glass, cooking salt, etc. Remark. The compounds CO, CO2, and CO3 are considered inorganic compounds, although they contain carbon. Stability of carbon. Carbon atom has 4 valence electrons. It shares 4 electrons to be stable. For this, it's said to be tetravalent, and that's why it's so important in organic chemistry, because it can do 4 single bonds, 2 single bonds, and 1 double bond, 1 single bond and 1 triple bond, or 2 double bonds. Comparison between organic and inorganic compounds. Let me go to watch this video.
Hello, I am Leonie Irina Putiara of Bogor Vocational School of Chemical Analyst. Our today's topic is the difference between organic and inorganic compounds. 1. Organic compounds are compounds which basically have carbon atoms as the main element in their structure, along with other atoms such as hydrogen, oxygen, and nitrogen. While inorganic compounds basically do not have carbon atoms in their structure. Generally, they are oxidizers, strong acids like hydrogen chloride, strong bases like sodium hydroxide, and salts like natrium chloride. 2. Organic compounds are the result of the activity of living things. But over the times, organic compounds can be synthesized in laboratory. For example, protein, fat, benzene. Inorganic compounds do not come from living things, but rather from mineral and natural resources. For example, oxygen and carbon dioxide, which can be obtained from the nature. 3. Organic compounds have covalent bond because they are composed of non-metal atoms. But most inorganic compounds have an ionic bond, which is a bond between metal and non-metal atoms. Only a few of them have covalent bond. 4. Because the bond is stable, organic compounds are difficult to react. Thus, the chemical reaction rate will be slow. To make it faster, we need a catalyst. Inorganic compounds will experience rapid chemical reaction because the bond among the atoms are not as stable as organic compounds. 5. The interaction among organic compounds is low and not strong, so that it is easy to break. As a result, the boiling and melting point of organic compounds is low. The interaction among inorganic compounds is strong, so it is not easy to break. Thus, it requires a high boiling and melting point. 6. Organic compounds do not dissolve easily in water because they have different nature. Most organic compounds are nonpolar, while water is polar. This is not in line with like dissolve like principle. To dissolve organic compounds, organic solvents, which are also nonpolar, are needed. While the nature of inorganic compounds is the opposite, which is generally soluble in water because it has ionic bonds. 7. Organic compounds have properties that tend to be flammable because their elements are mostly carbon. While inorganic compounds are relatively non-flammable because not all of them come from carbon. 8. Organic compounds are generally non-electrolyte, meaning that they cannot conduct electricity because they have no ions. However, inorganic compounds are generally electrolyte. It can conduct electricity because they have ions. 9. Most organic compounds are colorless, while most inorganic compounds are colorful because they are in group B on periodic table, and their natural properties are indeed colorful.
This is a comparison between organic compounds. They are characterized by the presence of the carbon element, while most of inorganic compounds do not contain the carbon element. Organic compounds, they are molecular compounds, while inorganic compounds, they are ionic compounds. These compounds are rarely soluble in water but soluble in organic solvents such as alcohol. These compounds are often soluble in water but insoluble in organic solvents. They are not electrolytes, while inorganic compounds, they are good electrolytes in aqueous solutions. That's why they are able to conduct electricity. Organic compounds come from living matter, while inorganic compounds come from non-living matter. Some examples of organic compounds: gasoline, oil, clothes, wood, perfumes. Some examples of inorganic compounds: table salt, drinking water, glass, the air we breathe. Application 1. Organic and inorganic compounds. Both organic compounds and inorganic compounds are used in our daily life. The list below shows the formulas of some compounds. This is the list from A to F. 1. Copy the table below and use it to classify the above compounds into organic or inorganic compounds. Let us start with the compound A, CH4. Since it contains carbon, such as an essential element, so it is an organic compound. Also, C2H5OH contains carbon as an essential element, so it is an organic compound. C, NH3, it doesn't contain carbon, so it's an inorganic compound. D, CH3COOH, since it contains carbon, so it is an organic compound. E, C2H4, it also contains carbon, so it's an organic compound. While CaCO3, although it contains carbon, but it is an exception, it's an inorganic compound. Representation of organic compounds. There are different types of formulas to represent an organic compound. Part 1, molecular formula. It represents the nature of elements and the number of atoms of each element that constitute the molecule. Example, ethane C2H6. In the molecular formula of ethane, we could observe that this compound contains 2 carbon and 6 hydrogen, so it represents the nature of element that constitute the molecule and the number of atoms of each element. Structural formula. It represents all the bonds that link together the different atoms, where all covalent bonds between atoms are represented by dashes. Structural formula of ethane. As we could observe here, it contains two carbon atoms linked by a single covalent bond. This is a single covalent bond between two carbon atoms. And each carbon atom is connected with three hydrogen atoms by three single covalent bonds. Condensed structural formula. It only represents the bonds between carbon atoms, carbon-carbon, without showing all the other bonds. Condensed structural formula of ethane, as we could observe, it shows only the bond between the two carbon atoms. Application 2. Write the structural and the condensed formulas of CH4, C4H10, C3H8. First, for CH4, we should write its molecular formula, structural formula, and condensed structural formula. This is the molecular formula of CH4, and this is its structural formula as shown, the carbon atom bonded with 4 hydrogen atoms with 4 single covalent bonds. And this is the condensed formula of CH4. Because we have only one carbon atom, we can't represent the bonds between carbon atoms only, so we have the same as the molecular formula. Concerning C4H10, this is the molecular formula of C4H10, and this is the structural formula. We have 4 carbon atoms bonded with single covalent bonds and surrounded by hydrogen atoms linked by covalent bonds. In the condensed formula, we could observe only the bonds between carbon atoms. We have CH3, CH2, CH2, CH3. For C3H8, this is the structural formula. We have 3 carbon atoms bonded by covalent bonds surrounded by hydrogen atoms. And in the condensed formula, we have the bonds between carbon atoms only, and we have CH3, CH2, CH3. At the end, if you please, review the video, resolve the applications, solve worksheet 1 on booklet concerning organic chemistry. Thank you for your attention and good work.